All right. So in today's first session, we will look at the architecture of the LAN network and WAN network. Okay. And in my introductory session, I explained you why is this first of all important, and let's just go through that as well. Because in interviews, when you are giving an answer for a specific question, like specifically the data flow, right? How a packet is flowing from one PC to another PC across the globe, or from one PC to a Google server, right? So when you are answering, there should be a structure to that answer, right? When the PC is sending a packet, which device does it go to? Then the next device, then the next device, next, like that it will finally reach its destination. Now what are these devices, how does it flow, what are the things that is happening in that particular segment of the network? If you are clear about it, you will be, your answer will be even more articulate when you're answer when you are when you're asked or when you're answering. So that is why we are going to understand the LAN and WAN architecture. Obviously, this is theoretical. When you actually go into the design of a network, right? When you try to see a design of a network, the topology may not be same. However, the hierarchy is going to be very much similar. So first, we'll look into the LAN architecture over here. Okay. And as we all know that LAN stands for local area network. Local area network. Right. Now, when we are speaking from a local area network perspective, it can be anything. It can be a residential area. It can be a corporate building as well. So it is easier to understand it from a corporate structure. The reason is we have lot of users in the same floor, right? Whereas in a residential area, what happens? The users are spread across different geographical locations. Okay. So when I'm explaining this LAN or WAN architecture, it's completely from a corporate or enterprise point of view. All right. Now, when I say enterprise, as I said, enterprise can be anything. It can be a small company, it can be a big company, or it can be a mega company like, the service providers like Airtel, or it can be a product company like Cisco or Amazon or a Google, okay, or a small enterprise company like, for example, let's say your local service provider guys, okay, Hathaway, ACT, these are small enterprise companies, right? So let's try to understand how do they try to connect each of your laptops or each of your mobile phones, etc., through the network. So let's imagine that there are different PCs. Okay, I'm just drawing 4 or 5 PCs over here. Okay, now on these PCs, obviously users are there, they are working. Now what happens is that these users, if they want to talk to each other, right, we can connect them directly. Okay, I can connect these users directly, or if I want these users to talk to each other, every user should be able to send packets or data to each other, I need to connect them like this, right? So obviously what is going to happen here is that this PC, one PC is connected to 4 different PCs, right? One PC is connected to 4 different PCs. We have 5 PCs altogether, and 5 PCs will be connected to 4 different PCs. So in total, we need 20 such connections. And you know that nowadays in most of the corporate companies, we do not use that physical PC. Most of us, not most of us, 99% of us, we use laptops, right? And we do not have ports or connectivities with which I can connect to 4 different PCs, right? All I have is even in my laptop over here, I have a USB cable. I don't have the Ethernet cable. I have a USB cable, then an HDMI port, etc. All that. Where do I have ports to connect to 4 different PCs? I don't, right? So keeping this in mind, what the network designers, what they thought, let us create a device, okay, which will help us to connect multiple PCs together, and they came up with switch. Before switch, there was a device called as a hub. We are not going to discuss about hub right now, but we came up with a device switch. Okay, then what happens, because switch has a lot of ports in it, right? These ports help different PCs connect together. Okay, and we also connect these two switches together as well. All right, now this is just a simple diagram. There are hundreds of users on a particular floor in a big company, right? Not there will not be only just two switches, there will be multiple switches, which helps multiple different users to connect to each other. Now this may also involve nowadays a Wi-Fi router as well, okay, with which we can connect our laptops or mobile phones, right? So what is happening is your PCs are connected to a switch and a Wi-Fi adapter, or we call it as an access point, okay, disconnected there. Now, because these PCs are getting an access to talk to each other without any hindrance, the first connectivity of these PCs to a switch and this whole layer is basically called as an access layer. Okay, it is called as an access layer. This is my personal definition, because the PCs are able to get an access to talk to different other PCs via the switches. That is why it is called as an access layer. Now, what happens is that there are different switches. Okay, for example, let's say you have another access layer switch over here. You have another access layer switch over here. Obviously, these switches again are connected to different PCs. Okay. Now, what as per the design rule, as per a design architectural design rule, it is said that no two switches, access layer switches, no two access layer switches can be connected directly. Meaning that these access layer switches, I cannot connect them directly. This is one of the design recommendation across all the vendors. Okay, it is for a security purpose. Okay, we'll when we are talking about design, we'll talk about that. But from a security point of view, it is said not to connect these switches together. Okay, so if you cannot connect these switches, access layer switches together, okay, and let's say that, let me draw one more switch. And let's say that one of this switch, let's say this switch goes down. Okay, these switches or these PCs cannot talk to PC number 3 over here, right? Because that switch has lost the connectivity and it will not be able to send or receive packet, right? So what do? We connect these switches to another few switches. Okay, and these switches are called as distribution layer switches. Distribution layer switches. So what do? We connect all these switches in the access layer to every distribution layer switch. Again, this is a design recommendation saying that all the access layer switches should be connected to every distribution layer switch, and the distribution layer switch should be in turn connected to each other. Okay. Now, there's not only one distribution layer switch. As I said, there are multiple access switches, and if you want all the access switches to be connected to every distribution layer switch, you need more number of distribution layer switches. So obviously you will have couple of distribution layer switches in the network. Okay, again, these are connected together. Now, please remember, these distribution layer switches again are connected to access layer switches. These access layer switches are in turn connected to different PCs. All right, like this. Now, then what happens? Let's say this distribution layer switch. Okay, this distribution layer switches are then connected to a core layer switch or a core layer router. It can be a router, it can be a router, or it can be a layer 3 switch. Okay, I hope you guys know there are two types of switches. There is a layer 2 switch and there's a layer 3 switch. Basically, what we do is in the access layer switches, access layer side, we have layer 2 switches. Distribution and core side, we have layer 3 switches. The difference between layer 2 is that it understands only layer 2 information, meaning it forwards data based on MAC addresses, whereas a layer 3 switch forwards data based on MAC addresses as well as IP addresses both. Right. So just to keep the whole diagram unanimous, I'm drawing a layer 3 switch. Right. Now, this layer 3 switch, basically a core layer switch, is connected to the distribution layer switch. Okay. Now, core layer switch is not just connected to one distribution layer switch, as you can see. It will be connected to multiple distribution layer switches, which then in turn connected to access layer switch, which then in turn connect to a PC. Okay, so now this core layer switch is basically a very powerful switch. Okay, it is a high-end switch which needs to process data at a very high speed. It needs to receive data, send data, process data, understand the data, or make decisions, forwarding decisions, make routing decisions, or make converging decisions, etc. A lot of things. It needs to do it very quickly. So the processing or the speed of this particular router or layer 3 switch is extremely high. So basically we deploy a high-end router or switch at the core layer. Distribution layer, not so high, but the processing should be faster. Okay. Now, in this whole hierarchy, we call this hierarchy as a 3-tier hierarchy. A 3-tier hierarchy. Because we have an access layer switch, access layer, distribution layer, and a core layer. Now, in this 3-tier hierarchy, where do we deploy VLANs? Okay, we usually deploy VLANs in this section, in the access layer and between the distribution layer switches, we deploy the VLANs. We have VLANs, we have inter-VLAN communication as well. Okay, inter-VLAN communication, then VTPs. Okay, then whatever VLAN related things that you can think of, all that is done here. Like then between the distribution layer switches, what do we deploy? Between the distribution layer switches over here, we deploy spanning tree protocol. We deploy HSRP over here. Okay, we also deploy OSPF or EIGRP or some other routing protocol. Why? Now you may be thinking, why do we need OSPF here? The reason is, as I said, we are connecting different access layer switches to the distribution layer switches. Obviously, the IP addresses of these PCs, right? The IP addresses of these PCs, they need to be sent across. They need to be shared between the distribution layer switches. They need to be shared with the other switches as well, right? So let's say this guy has a 10.1 1.0/24 set of IP addresses. Okay. Over here, it has 10.1.1.10.1.2.0/24. Okay. So, and moreover, they are part of the same enterprise network. The IP addresses need to be exchanged, right? You are sitting in your company, okay, and you are talking to the HR of your company or the IT team of your company. There's a high chance that your IP address and the IT team guys' IP address are different. However, you are able to talk to each other. Why? Because the routing is happening. Routing is happening there, right? So you need OSPF so that the IP addresses can be exchanged between the distribution layer switches. Okay. Now, here, between the distribution layer switches and the core layer switch, again, you may deploy HSRP. Okay, you may deploy any routing protocol so that the routes can be sent out, can be also received. You perform NATing. You perform NATing at the core layer switch so that the private IP addresses can be converted to public IP addresses and vice versa. You need this. Okay. So keeping this in mind, when you are talking about the packet flow from one PC to another, if you have this 3-tier architecture in your head, it will be easier for you to explain. Okay. A better tip that I would give is write down your answer. Let's say you're trying to explain this packet flow. So tell the interviewer, like, show them that I have a paper and I have a paper, like, I have a paper, I have a pen, and I'm I'm drawing so that my thought process is very clear. Okay, so you would start, there is a PC has this IP address, it is connected to a switch. So you start drawing on the paper. As you're drawing on the paper, you start explaining. Okay, as you start explaining, your thought process is even more clear. And when your thought process is even more clear, what you're saying is even better. And when it is better, the interviewer will be interviewer can understand what you're saying easily. Okay, so it is always a best practice to draw or visualize your answer. When you're visualizing your answer, especially on a paper, it is easier to explain. All right. Any question till here? Anyone? Or anyone would like to add something?
Like this core layer switch should be connected to internet, right?
Yeah,
I
yeah.
mean, like,
I'm coming to that part. Yes, I'm coming to that. You are right. You are absolutely right. Yeah. Any other question? Anyone? Now, this core layer switch. Okay. This core layer switch has different roles. It is acting as a default gateway. What is a default gateway?
Exit point of network.
Correct. Exit or entry point of your network. It's a default gateway. So, like, our gateway of India and Bombay, right? So people olden times through when shipping used to happen, only shipping was there. It was a sea route. People used to enter through the gateway of India. That's why it's called as gateway. So you either enter or you exit through this particular router or a layer 3 switch, right? It acts as a default gateway. Now it is acting because it is so powerful, it is so huge, and it can accommodate so many data at once. Service providers, they think it is wise to connect multiple LAN networks or multiple distribution layer switches of different networks into one core layer device or couple of core layer devices. Again, this is a very theoretical diagram. when you go into a live network and check the core layer, probably you may see 2 or 3 core layer devices connected together. Okay. Layer 3, etc. Again, they are serving the same thing. This guy must be connected to a distribution layer switch. Then it will be connected to an access layer switch. Then he will be connected to a PC or a user, something like that, right? So, as I said, this layer 3 switch is not just connected to one single network. It may be connected to different networks. And again, when it is connected to different networks, all of them are basically a private network. For example, this layer 3 switch, again, hypothetical situation, is, let's say, connected to Google network, Google's data center. Here it is connected to Amazon's network. Okay, here then it is connected to, let's say, give me some company, Netflix, let's say, right? It is connected to Netflix network as well, private network as well. So what is happening? It is acting as default gateway to a lot of networks, not just one, but many. Again, hypothetical, it may act as a default gateway for just one network. It may act as default gateway for a lot of other networks as well. Again, depends on your money, depends on how much you want to spend. Are you okay to share your core network with different networks? Okay, security is guaranteed always. Okay, Google will say, I want security, I don't want Amazon people to log into my network. Obviously security will be given. Security is a separate part. However, are you okay to share? Okay, so if considering all that, let's say this layer 3 core layer switch is connected to different networks. Obviously, all of them are private networks. When I say private networks, they have a private IP addresses. They do not have a public IP address. Okay. Now, what will happen? We will create natting over here so that we will do a natting so that the private IP addresses can be converted to a public IP address. Correct? Now, this core layer network over here. Let me, instead of drawing vertically, I'll draw this horizontally. Okay. So over here is your core layer switch or a core router. I'm just making this as a router. Okay. And as I said, it may be acting as a private or a default gateway router for a lot of other networks. Right. Now, before I move on, this was your LAN segment. Okay, this is your LAN segment. Okay, where all your LAN side protocols are running. You have VLANs, VTP, spanning tree protocol, HSRP, NATing, OSPF, sometimes BGP also. And if you are into a data center side, here you have VXLAN running, SD-WAN, etc. All that running here. Okay. As I said, I do not have much of a working experience in SD-WAN and security. That is why I have not brought those things into this picture. All right. If anyone else has to say that, here a firewall comes or here we can use this as SD-WAN, you are free to add in your opinion as well. Yeah, Prashant, you're saying something? Srinivas, you're saying something?
No.
Yeah, in place of core, no. So normally we use SD-WAN recent times, like in core layer, right?
Okay.
In our company
Okay.
also we are using how it is connected now from distribution to in core level. There is a one Velo Cloud SD-WAN. So from there it is going like SDP like that. Sure.
All right. Okay. Okay. All right. So this is your core layer router. Okay. And as I said, it is can be connected to multiple users. Okay. Let's say this is user number. Okay. When I say, okay, LAN number 1, so that LAN number 1 and LAN number 2. Okay. Then what happens? This core router, okay, which is actually a part of your network, okay, or multiple networks as well. Okay. In the moment the data crosses your core router, okay, in networking, we say that now it has gone to the service provider network. Okay, now it has gone to a service provider network. Now, from a very layman term, okay, a person who does not know about computer networks or who does not know how internet works, when you say service provider, for him it is Airtel, for him it is Jio, okay, or anyone or any other company which gives him the access to internet. Okay, for him or her, that is service provider. But from a networking point of view, a service provider is an organization which helps you connect your network with multiple other networks. That is what in networking a service provider is. Okay, Google is a server. Okay, Google is a server. We are accessing Google server through some service provider's network. It can be an Airtel, it can be Vodafone. If you are using an Airtel network, you will be accessing Google network through Airtel network. If you have a Jio network, you will be accessing Google network through the Jio network. Okay. So as I was saying, the moment your data leaves the core router, we say it has left the enterprise network and is into the service provider network. So now we are just going to understand how service provider network is built. All right. Now this core router is connected. Okay, let's say this is the service provider network, and usually in networking, a service provider network is drawn as a cloud. Okay, so this core router is connected to a router of the service provider. Okay, I'm writing that as a PE router. Now, when we are looking at the data flow from a service provider's point of view, we do not call this core router as core. We call that as CE router. I'll explain you that now. CE router, or we call this as a customer edge router. Okay. Now, from a service provider, he is getting some kind of data. Okay. Where is he getting a data from? He is getting data from his customers. Okay. Now think from a service provider's perspective. He is getting data from a customer. For him, his router is connected to a router which is on the customer side. So it is called as a customer edge router. Now the customer edge router is connected to a router which is on the edge of the service provider network. That is why it is called as a provider edge router. Provider edge router. Okay. Obviously, all this, the edges of the cloud will also have routers connected to them, right? So we call them again as a PE router over here. Now, the routers inside this cloud network or this service provider cloud is called as P router or provider router. Simple. Provider router. Okay, because they're inside the provider's network and they're not at the edge. If they're at the edge meaning they will be connected to customer edge network, right? So this PE router will be then again connected to a CE router or a customer edge router. Let's say that this is Amazon's network. Okay, this CE router, okay, this is the again a core layer router for some LAN network will then be connected to a distribution layer switch. Then this distribution layer switch would be connected to an access layer switch, will then be connected to a PC. Okay, so this network over here may be an Amazon network. So this is how your Amazon network or Amazon's one branch is connected to Amazon's other branch across the globe. Okay, now it is not necessary that end-to-end connectivity is given by one service provider. it can be given by multiple service providers. You may be going through different service providers. Okay, you may be going through Jio, you may be going through Airtel, then Tata, etc. Okay, all of them are connected together. Okay, so your packet may be going through just one single provider, or it may be going through different providers as well. It depends of how the connectivity is happening. Okay. Anyway, from in the interview, they may not be suggesting that you are connected to different service provider network. Now tell me how the packet is flowing. No, they're not going to suggest like that. They'll be thinking only from a one service provider scenario only. Now, in this whole scenario, what are the different type of protocols we will come across? Okay. Now, inside the provider edge network, many different protocols may be seen. You may see different IGP protocols. It can be OSPF. Mostly it is going to be an OSPF because it is a service provider. Service provider may not be depending on just one single vendor. Okay, he may be depending on different vendors based on his budget. He may be using Cisco. He will also use Juniper. He will also use IBM, Nokia, Calix, Ciena. A lot of other different vendors put together is like put together, and the service provider creates his own network. So most of the time, 99% of the time, you will see OSPF into it because open. OSPF's first word itself is open. Open means open standard. Any vendor can use it. That is why you will see OSPF running inside. Second thing, you will see MPLS. Okay, MPLS you will see. You will also see BGP. So BGP, and you may also see VPNs. You may see VPNs being created. You may also see DMVPN also here. All right. So you may see such protocols being executed in the service provider cloud network. Now, between the CE and PE, it completely depends on the agreement between the service provider and the customer. He may deploy BGP. They can deploy OSPF. Okay. Or yeah. So So BGP and OSPF either. Okay. Let's say this guy wants to use. He says I want to use OSPF. Okay. Provider will say, okay, fine. I don't have a problem. You just send me your data. I will redistribute it into BGP. Okay. This is what it's going to happen. Then. Yeah. Okay. Not just BGP and OSPF. There is one very critical thing that will run. That is VRF. Okay. VRF stands for virtual routing and forwarding. Can just someone explain VRF quickly? Anyone?
VRF is like dividing one physical router like into virtual router. Like one brain is divided into multiple brain. So basically what happens, service provider on provider router, like multiple customers are onboarded on the same PE. So how to separate their routing tables, VRFs are configured on provider router for different customer to separate their routing tables.
Absolutely right. Absolutely right. Okay. Now, how many of you understood Prashant's answer? And how many of you did not understand or want explanation? How many of you understood? Just raise hand. I mean, because he has a lot of experience, he said in his own words. How many of you understood what VRF is? No one?
I got it.
Okay, fine. So let me give you a very simple example. Okay, I'm just erasing these things just to declutter the diagram. So as I said, this core router or the customer edge router over here, core router from a LAN perspective, customer edge router from a service provider's perspective. This core router or a customer edge router, as I said, is connected to different LAN networks. Okay. Please remember, in a LAN network, we just discussed, all of them would have a private IP address. A private IP address. Okay. So, I can even show you right now. Can someone open their command prompt? Or if you're on a laptop, or can someone open their command prompt?
Yeah.
Sorry. Type IP config.
Okay.
Okay. Obviously, you're connected to Wi-Fi. What's the IP address of your Wi-Fi?
For me is 192.168 or 63.1.
63 dot. Okay, no problem. So what I was trying to tell you was, if you see, our first two octets is same, 192.168. Okay. And because it's a private IP address, there's a high chance that my IP address 192.168.1.33, it's a private IP address. Private IP address is not unique. Private IP addresses are not unique. Okay, there's a high chance that somewhere, okay, someone, if he does an IP config, he will also say this IP address. I remember I was taking a class last year, and one of the students, he said his IP address is also the same, 192.168.1.33. Okay, now why is this interesting? The reason is, obviously, when you are from a customer edge router, okay, when you're from a customer edge router side, there is a high chance that this LAN network and this LAN network may be using the same private IP address space. Okay, from an example point of view, okay, he's using a 10/8 IP address. This guy is also using a 10/8 IP address space. Right, now LAN 2 sends a data, LAN 1 is also sending a data. Okay, now when the data is sent out, it's okay. It is okay to whichever destination it wants to go, let it go. Let's say this guy sent a data to, for example, 20/8, for example, and this guy sent a data towards 21/8. Okay, now when the data is coming back, how will this CE identify to which 10/8 should it send to? Right, because when the data is coming back, the destination IP will say 10/8. Now, which 10/8 is it talking about? Is it talking about LAN 2s or is it talking about LAN 1? This is a confusion over here. Okay, and for this purpose only, we created something called as VRF. Okay, so we created VRF, where we say that this interface is part of something called as VRF A, for example. This interface is part of VRF B. Okay, now what happens? This 10/8 gets associated to VRF A. This 10/8 gets associated to VRF B. Okay, then what happens? When the data is being sent, it is sent along with the VRF information also. So when the data comes back, the customer edge router would easily identify, because now in the destination IP side, it not only includes 10/8, but it also includes the VRF information. So now it is easier for the customer edge router to identify which 10/8 is it talking to. Is it talking about VRF A or is it talking about VRF B? And based on that VRF, it will forward the data. This is why we use VRF, virtual routing and forwarding. Okay, any question understanding this, or should I explain this once again? All clear? No doubts?
No, it's so far clear.
Yeah. Mohit, Vikas, sorry, not Vikas, Vivek.
Yeah, if you could explain once again.
All right.
Alex, I am using same network actually, which 192.168.1. Same
33.
private network. Yes.
33. Yeah,
Not
see,
33, same net is /24. Okay.
okay.
Same
1.0, 1.0.
1.0, yes.
Okay.
Like VRFs are created on both the sides, like C side and P side as well. Provider edge side also.
Yeah, it can be done. It can be done. Yes. It
But
depends
if
how this. It depends how the service provider wants. I mean, see, it's obviously it is like I just gave you a very hypothetical diagram. What happens is this PE router would be connected to different CE routers. Instead of creating a VRF over here, provider edge router would prefer creating VRFs over here because he is connected to different CEs, right? So, and those CEs are connected to different private LAN networks. So instead of creating VRFs on the CEs, he would say, leave the VRFs on your side. Do not create VRFs, or even if you create VRF, do not tell me. I'll just take it.
Okay. Yes.
Right. So from a service provider network's point of view, it is easier for him to create VRFs on his side because then he is responsible to manage it. It is easy for him
Yes.
to manage it also.
Yes, got it. Good.
Right. Okay. So I was saying, in real time, the LAN networks, they have private IP addresses. Okay. And there is a high chance, as just Tarun said, he has an IP address space of 192.168.1.0/24. Even I have the same IP address space. Okay. Probably someone in his locality may have the IP address of 1.33. Okay. What's your IP address, Tarun? Exact IP address? Tarun, can you hear me? All right, no problem. So as I was saying, there is a high chance that
Tarun or me? Srinivas.
Oh, it was you. It was you. Okay, yeah. What's your IP address?
1.5, 192.168.1.5.
1.5, right? So obviously, someone in my locality, okay, someone probably my neighbor, okay, may have this IP address space 1.5. There's a high chance. Okay, see, where do you live, Srinivas?
I'm in Hyderabad.
Hyderabad, right? He's in Hyderabad. Okay, let's say assume that I also have an IP address of 1.5. I am in Pune. Right? We are two places apart. Okay, like literally Hyderabad is on the eastern side, Pune is on the western side. Okay, so we are on the two different sides of India, right? Even then, we have the same IP address space. Let's say that someone in Pune itself, he has an IP address that is very similar to mine. Not very similar, exactly mine. Okay, so when our data is sent from 192.168.1.5 to, let's say, 8.8.8.8, which is Google's DNS server, and this guy 192.168.1.5, he also sends some data to 8.8.8.8, right? Out of the CE router, it is okay for him. Okay, he'll do a he'll do a natting. Let's remove natting for one this thing. Okay, from this whole discussion, let's remove natting. We are just trying to understand VRF. What is the purpose of VRF? Okay, so you remove. Oh, sorry, yeah. When the data is being sent out, okay, this guy sends with a destination IP of 8.8.8.8. Right. He also sends with a destination IP of 8.8.8.8. Now, when the returning traffic is coming, and the returning traffic hits the router, right? Both of them will have an IP address 192.168.1.5. 192.168.1.5. This also will have a destination IP of 192.168.1.5. Okay. Now, how will this CE router or the core router over here decide which 192 is it trying to go to? Is it from a LAN 2 network or is it from a LAN 1 network? Right? It is completely aware of. There is a high chance that this traffic, instead of going towards LAN 2, it goes over here, and this traffic goes over here. Okay, and what happens? The user in LAN 2, he may get a different result. Though he has pinged google.com, but he has pinged google.com some other port number, and he got a different response, which he was not expecting, right? So this is where the confusion comes. How is this customer edge router going to differentiate similar set of LAN IP addresses? To differentiate such similar IP addresses, we created VRF. Okay, so we said this LAN network will be connected to the interface VRF A on the CE router, and this LAN network would be connected to the interface VRF B. Yes, we create virtual interfaces. Because it is virtual, we create virtual interfaces VRF A, VRF B, and we connect this interface over there virtually. So what happens? Your LAN network over here gets bind to the VRF A interface, and this LAN network gets bind to the VRF B interface. So now what happens when the data is being sent? Okay, to destination 8.8.8.8 with a source IP of 192. It also gets sent along with VRF A. Here also it gets sent with 192 with a VRF B. So when the returning traffic is coming, it also carries this VRF information. When the returning traffic is carrying the VRF information, this customer router would know to which LAN network should it send. It will read the VRF A and it will forward the traffic to LAN number 2. It will read VRF B and it will forward the traffic to to LAN number 1 over here. That is how you differentiate. And this is the purpose of VRF. Virtual routing and forwarding. So this VRF is not necessary that you have to create it on this customer edge router. You can create it on the provider edge router as well. Over here, you can create multiple VRFs over here. All right, Mohit, is this clear now?
Yes. Thank you.
Anyone else? Any question? Okay. So,
सर मेरा एक
as I
लास्ट
said,
क्वेश्चन था कि जस्ट वांट टू नो कि सपोज वी क्रिएट VRF on CE, so it's not necessary to create on the other end router, right?
no, it is necessary.
It's necessary, okay?
Yes.
So if I have a router A or router B, so if I created VRF on router A only, so as per means if I don't create VRF on B, it won't communicate, right? We need to like configure on both the side. It's not a single site like a configuration. We need
Correct.
to configure on the both end, right?
Yes, yes, both
right?
end.
Okay.
Thank you, sir. You need to create VRFs on both the end, because once you create, okay, and even if you when you try to debug, okay, it will if let's say here this is CE1 or let's say P router, okay, PE1 router, okay, and this is the cloud network, and this is PE2 router. Okay, now here if you create VRF, okay, here also you created VRF, but you leave here, if you do not create VRF here, and if you try to debug, okay, when you try to debug, it will receive VRF information. However, it will not respond to it because you have not created VRFs. Along with VRFs, you need to create something called as route distinguisher and route target, which I'm not going to talk now. When we are talking about L3 VPN, I'll talk about that. Okay, so VRF information will be sent. However, the PE2 router will not be able to understand it because we have not configured. So when you debug it, you will see the errors. Not the errors, you will see the VRF information being received. However, PE2 is throwing error that it is not able to understand it. So it is a bi-directional process. And as I said, it makes more sense for PE or the provider edge router to have VRFs. It is because this is completely under the service provider's control. He knows what VRF he has to assign. He knows which are the provider edge router where he needs VRF, where he does not need VRF, what VRF has it been assigned, what RD, RT value, route distinguisher, and route target values have been assigned. As I said, these route target, route distinguisher thing is part of L3 VPN, which we'll discuss probably in the end of the session, in the end of the course, right? So those things, all of it is under the service provider's administration, and he knows it, and that is why it makes more sense to let the service provider make that decision of creating VM instead of the service edge. So not service edge, customer edge. Any question? Any other question? Or anyone else would like to add something here? Okay, if you're wondering where multicasting happens, you guys are wondering where multicast happens. Multicast is of two types. Okay, one is on the LAN segment. The other is between routers or in the WAN segment. Okay, in the LAN segment, we call it as IGMP. Yeah,
IGMP and WAN side PIM.
PIM. We call it as PIM. Okay, so I'm not sure if any one of you have been asked multicast question, please feel free to, because I've never been asked, so I do not know what kind of questions are asked in my.
I have been asked when I appeared for interview 2 months back for JP Morgan.
Okay.
So they have like it's like they are using multicast a lot. So within IGMP there are IGMP version 1, version 2, version 3. And in PIM side, WAN side, like there are two mode. One is sparse mode, dense, and they are asking some share tree. I remember some. So at that time, I have just started recently learning after, because it was surprise for me in that they have started suddenly asking multicast. So like this, whenever any PC tries to join any multicast stream, it sends IGMP join request, it reaches to the router. So all at that time on a high level, I said all this, but I'm not very good multicast right now. So
okay, no problem.
But they are asking for packet flow of multicast.
Packet flow of multicast. Okay. It can be, yeah, no problem. I can take that. Not packet flow. I can explain how multicast basically works.
Like they given me one scenario, like there is a PC which is connected to a switch and which is connected to a router, and after that you have a multicast stream server, right, where you have hosted your multicast stream. It is in your data center. Okay. Now any user which is at branch side is trying to access that multicast stream. So he was just asking me, walk me, what are the process will happen from your branch
that was a very, actually it was not packet flow. He was asking the different types of IGMP messages. Right. So let's say in multicasting, when the PC PC sends actually a report message. Sorry, report or query. I forgot even I forgot. It sends a query message. Query report. Yeah, sorry. PC sends report messages. Routers send join message. Yeah. So the router which is connected to the multicast server will send a query message if does anyone wants to join the service, right? Then the switch then broadcasts it to all the PCs. If the PC wants to join that particular multicast, it will send a report message, right? Then the report message goes to the switch then sends it to the router then sends a join message to the multicast streaming server, and then it starts to receive the streams, etc. So as I said, again, I explained in a very high level
Yeah.
this thing. Yeah, so Mohit, your question is, every topic in networking has a packet flow. Why so? Yes, the it it's not packet flow as Prashant is saying. It's not. His interviewer did not ask him a packet flow, but he asked him the process of multicasting. Okay, so let's say that if I say two routers, there are, let's say, three routers. I have enabled OSPF, right? I have enabled OSPF, and on all these three routers, there are this is the loopback address, these are the loopback addresses, and these are the networks that are connected to these three routers. Let me draw that. Let's say R1, R2, and R3. These are the three routers. The loopback address is 3.3.3.3, 2.2.2.2, and 1.1.1.2. This guy has 30/8 network. This guy is connected to 20/8 network. This guy is connected to 10/8 network, right? And when let's say if the interviewer says, tell me the packet flow in this OSPF. If I enable OSPF and all these three routers, what is going to happen? What is the packet flow? Here, he does not mean packet flow as such. It means basically the process of how these three routers will form OSPF, which will there be a DR-BDR election? Will there be not a DR-BDR election? If there is a DR-BDR, which will become a DR, which will become a BDR? Then basically he's asking you all the OSPF states. How will the routers process in it two-way, all that different states? How will they exchange the DBDs, etc.? Basically, that is the packet flow. Okay, when the original question is asked, what happens when you type google.com? That is a different packet flow. Here, the word is packet flow, but it is not actually a packet flow. It is basically the process of how OSPF will work between these three routers. So when Prashant's interviewer asked what is the packet flow, basically he's not asking the packet flow. He's basically asking the process of how a particular user will join a multicast stream. Let's say that today there is an IPL match that is going to start at 8 p.m. IST. Okay. So when you open Hotstar and you click that link, what is happening? So that is a process. Your laptop is going to send some message to the nearest switch. That switch is going to send some message to the nearest router. The router is going to finally send that message to the Hotstar server. The Hotstar server is going to send the data towards your PC. How is that happening? So basically, that's a process instead of packet flow, right? So everything has a packet flow based on the process, step by step, what is happening. Basically, that is what you call it as a packet. Clear? Any question? Anyone else? Anything? All right. So I'll stop the class over here, and I'll see you guys tomorrow.